Our next property we get the opportunity to talk about is completing the square. Now, completing the square is just an algorithm to get to our answer. Notice in zero factor, we were limited with only problems that could factor. In the square root property, we were limited to only problems that had a x squared term, and that was it. With completing the square, the world is your oyster. Everything is out there, everything is available. You can solve any quadratic using this method, which is super cool. And you are going to have to know this method because in order to work with circles that we do later, you need to know how to do completing the square. Okay, let's do this thing. So, my first example is x squared minus 4x minus 14 equals 0. Now, I told you completing the square is like an algorithm, so we're going to write our steps off to the side. The first step in completing the square is making sure your a value is equal to 1. Lucky for you, all of the a values in the problems I'm going to give you are going to be equal to 1 because they will be in circles as well. So that's really the concept I want to make sure we get across. The second step in completing the square is to isolate the variables. Now, my extra little twist I like to throw in there is this is also when I put in the plus blanks. So check this out. I now have x squared, because that's a variable, so my two variables I'm isolating are the x squared and the x, minus 4x plus blank equals when you add 14 to the other side, and you also put in plus blank. So that's what I mean by putting in the plus blanks. And this third step is the kicker. This is your completing the square step. So with your completing the square step, the first thing that you want to figure out is your b value. Then you're going to take your b value, divide it by 2, and then take your b value that's divided by 2 and square it. When you divide that b value by 2, that value is what's going to go in your parentheses. When you square your divided by 2 situation there, that is what goes in your plus blanks. The whole purpose of this is to get it to where you are completing a square. So you want something to be squared here. So if I look at this value in my parentheses, squared, that's the goal, is to have parentheses squared equal to some number because we just did problems like that. So if I'm going to take my 4 and then divide it by 2. So 4 divided by 2 is negative 2 because you have a negative sign with the negative 4, so that's also a negative 2. Then you square it. So negative 2 squared is positive 4. And whatever you do to one side of your equation, you got to do to the other. So go ahead and put that 4 on the other side. That's what keeps it an equation because it is balanced. They are equal. Then add it up. 14 plus 4 is 18. Rock and roll. Now what do you notice about this? Yeah, this is what we were just working on. So if you look at this, we can now apply the square root property. And that's why on that very last example I said leave it. Now you get this set up, you complete a square so that you can ultimately use the square root property. Let's do it right now. When you square root both sides, anytime you physically make the square root symbol, what do you write? Plus or minus. Now we can go ahead and break down this 18 to be the square root of 9 and the square root of 2. So I'm going to go ahead and write this as 3 root 2. Just to make it easier. Saves us a step as we go through there. Now, is x by itself? Not yet. We're going to add 2 to both sides. Now, when you add that 2, where does it go? In front of the plus or minus. Good. And again, how many answers do we have? 2. We have 2 plus 3 root 2 and 2 minus 3 root 2. Now, something I will tell you, when you're doing your homework, make sure if it says use completing the square, You have to use completing the square. If you do not use completing the square on your test, I'm going to take off all points for that problem, regardless of if it's right or wrong. The whole purpose of this method is the fact that you use it outside of solving quadratics. So I want to make sure you know how to use this method. Let's do one more example like that, just to make sure we have it down pat, so we're not stopping and starting in between steps and we're just rocking this thing. So here is example 3b-ish. If I have x squared minus 10x minus 20 equals 0. Now, when you solve a quadratic, you always want to go through your methods. Notice, there is no way for me to factor this, so zero factor property is out. If I'm looking at this problem, there's an x term, so I know I cannot use a square root property. So, next option available, complete the square. So let's do that right now. Alright, so we know we're going to be using completing the square, so let's go ahead and do that. I'm going to go ahead and add 20 to both sides, and remember when you isolate your variables, we're going to put in our plus blanks. Good. Okay, so the whole purpose with completing the square is to, guess what? Complete the square. So I have x minus, because the minus sign I know it's minus, is going to be something squared equals some number. Well, what's negative 10 divided by 2? Negative 5. Good. Then you square that. Notice it's squared. Square that and put it in your blanks, giving you 25. And remember, whatever you do to one side, you have to do to the other. So 20 plus 25 is 45. Cool. Now, square root both sides. Anytime you physically make the square root symbol, you need to write plus or minus. And notice, 45 is broken down to be 9 and 5. So this is 3 root 5. Cool. Now x is not by itself, so let's make that happen. I'm going to add 5 to both sides. Where's that 5 go? In front of the plus or minus. So 5 plus or minus 3 root 5. Now remember, when you write your answer in My Math Lab, you have to break it up. So this is actually 5 plus 3 root 5 and 5 minus 3 root 5. Again, when you're looking at your problems, squared is the highest exponent, so you have your 2 answers. Good, good. All right, so make sure anytime your problems say complete the square, that is the method that you do in order to make the problem work. Cool.